In this video, we will cover an FMCW manual altitude simulation using the ALT8000 rad-out test set. Select the simulation function key. You have control and UT parametrics. We've already performed the setup. We're ready to test our FMCW type rad-out. The only setup we need right now is to tell it whether we are in manual mode or profile. And we're going to do a manual simulation. So we need to set it up to manual simulation. Then we need to select the altitude that we want to simulate. In this case, we can just start with 0 feet. The RF level offset is used to add additional power to the received side of the unit under test, and to determine if there's an attenuation problem. It can drive past an attenuation of 10 or 20 dB to determine if there's an attenuation issue in your path. No additional setup is required on this page. Select the Run button to start your altitude simulation. It's detecting the power, detecting the pulses. Once it's running, you can see that the frequency, the UUT power, FM deviation, and the sweep rate, and the UUT type are all displayed. That's information from the transmitter of the unit under test. On the control side, you can see that we've set it up for 0 feet in a manual simulation. And from the altitude selected and the power that is detected, it was determined that the loop loss would require an RF level of -24 to -26 dB nominal value for the receiver to be happy. And so that's automatically set up for you. And if everything's working and the indicator displays 0 feet on the aircraft, everything is happy. There's no problems with the unit. No problems, at least on the receive side at this point. Then you'll need to check your transmit parametrics. Your frequency, typical value is 4.3 gigahertz, and we're measuring well within tolerance. Power is going to be determined by the altitude that's selected and can be found in the operations manual for the rad-out that you're testing. FM deviation will determine the strapping of the rad-out. It's strapped at a certain frequency to prevent crosstalk with the dual system. Your sweep rate is determined by the altitude that's selected as well, and can be found in your user manual for the rad-out that's under test. If all UUT parametrics are within tolerance and the correct altitude is displayed in the cockpit, the rad-out under test is functional. If the UUT parametrics are good and the indication does not display 0 feet in the cockpit, you could have a receive problem. At that point, you could add more power to the RF level offset to determine if you have attenuation in your coaxes. If you were using couplers and you had the good transmit parametrics and you believe there was a problem on the receive side, you could disconnect from your couplers and then go direct connect to the rad-out under test to determine if it's a problem in the antennas or the coax. If everything works by direct connect, then you know that you have a problem in the coax or the antenna. You can troubleshoot those and then retest. If the test doesn't work direct connect, then the problem is in the UUT, and you can continue with the replacement of the UUT. In order to select a different altitude, you select altitude pause. You'll notice that the current altitude window opened up, the lock went away, and it turned flashing yellow. This indicates that it's a temporary setup that the user can change. Click in the current altitude window and enter your new value. Select feet or meters. The altitude displayed in the aircraft should match the current altitude. This test can be performed to test the different ranges within a rad out, or to simulate altitudes to test other systems on the aircraft. To test the entire range, just click on the current altitude again, select the next range that you would like to test, select feet or meters, and the new altitude should be displayed in the cockpit of the aircraft. Continue this process until all ranges have been tested. If your rad out should turn off once it reaches its max altitude, then you can test that function as well. If it's a, say, 2,500 foot rad out, and it should not be working at 2,700 feet, enter 2,700 feet. And the display should blank. What you want to ensure is that your power from your transmitter is still good. That should stay good. The rad out should stay operational, but the display should blank to indicate that you are above the rad out's usable altitude. To perform an altitude change, I can stop the simulation. Select the altitude rate that I intend to use. In this case, I'll select 1,000 feet per minute. Once you've selected a rate, you can see that the screen changes and allows you to select a start altitude, which I will start at 0 feet, and a stop altitude, which I'll stop at 2,000 feet. This is going to start at 0 feet and climb to 2,000 feet at a rate of 1,000 feet per minute. Select the Run button, and you should see 0 feet on the indicator in the cockpit. Once the test is running, you can verify that the current altitude displayed on the test set matches the altitude displayed in the cockpit to test linearity. The altitude would continue to climb till it reaches the stop altitude, and then it will halt at the 2,000 feet. Once the test is complete, the current altitude will display the 2,000 feet, and the indicator in the cockpit should display 2,000 feet. I can then stop the test. If I choose to reverse that test, I can click the reverse button and go from 2,000 feet down to 0 feet at whatever altitude rate I input. To return to a manual test, I can remove the altitude rate, set that back to 0 feet per minute, and you can see now I only have one window for altitude, and so I can just put in a fixed altitude and return to a manual test. You'll see that the current altitude will update to my altitude setting and should match the cockpit indicator. That is all the steps to performing a manual altitude simulation to your aircraft.